Hi you two, welcome to your math lesson for today. So what we're going to do is we're going to start off with some fluency, and in fluency this week we're going to be looking at bridging 10. So that is when we're adding two numbers together and we end up going across that 10 boundary. Okay, so have a look here. My first addend is 7 in each of my equations, and what I'm doing is I'm adding a number to 7 that will take us past 10. Now I know that all of these calculations will give us an answer bigger than 10 because I know my number bonds to 10, and I know that 7 plus 3 will equal 10, so any number bigger than 3 will give us an answer bigger than 10. So let's have a look here. 7 plus 4. Well, even though I know it's going to give me an answer bigger than 10, I can still use my number bonds to 10 to help me here, because once I get to 10, it's a simple matter of adding the remaining ones. And it's really easy to add numbers to 10, because if I've got 0 ones like I do in the number 10, then the number of ones that I am adding will just replace those 0 ones. So let's have a look at this in practice. 7 plus 4. Well, instead of adding the 4 all in one go, what I can say in my head is, well, I know that 7 plus 3 equals 10. So this first number that I'm going to partition my second addend into is going to bond with this first addend to make 10. So in my head this is the process that is happening in my head. All I'm doing is I'm writing it out, and the faster we get at this, the more efficient we will be at doing this in our heads. So 7 plus 4, I'm not going to do that all in one go. What I can do is say, well, I do know that 7 plus 3 equals to 10, but I don't want to just add 3, I want to add 4. So how many more do I need to add? I need to add 1 more. So if I know that 7 plus 3 equals 10, then in my head I can do 10 add 1 more is 11. So that would give me the answer of 11. Why don't you pause the video and have a go at doing the rest of these calculations yourself, working out what you're going to partition that second addend into, and then we'll go through it together and you can play the video. Lovely, well done for having a go at that year two. So starting with 7 again, my first number that I'm going to partition my second addend into will bond with my 7 to make 10. So I know that 7 add 3 is equal to 10, but I didn't want to just add 3, I wanted to add 5. So that means I've got 2 more to add. So 10 add 2 equals 12. And you can see that down here as well. I've got a full tens frame there being bonded with my 7 and 3 together. And then I've got 2 more. Now the red counters represent my first addend, and my blue counters represent my second addend. And you can see that I've had to partition that second addend into a 3 and a 2 because I was making 10 first. You could also call this the make 10 strategy. Right, let's have a look at this one then. So the first number that I'm going to partition my second addend into is going to bond with this 7 to make 10. And I can see that 7 plus 3 makes 10. But I didn't want to just add 3, I wanted to add 6. So that means I've got 3 more counters to add to make my whole 6. And I know that 7 plus 3 equals 10, and 10 plus 3 equals 13. And then 7 plus 8, well, the first number that I'm going to split my second addend into is going to bond with my first addend to make 10. And you can see that 7 plus 3 equals 10. But I didn't want to just add 3, I wanted to add 8. So I've got 5 more counters to add, but I'm adding that to 10 because I already know that 7 plus 3 equals 10. So 10 plus 5 more equals 15. Can you see these 5 ones that I'm adding second are replacing that 0 in my 10 because I had 0 ones when I made a full 10, and if I had 5 ones, they'd simply just go into your ones column. So what we've effectively done is we've turned this into a 2-step addition, or an addition with 3 add-ins. So effectively what we have done is 7 plus 8, but instead of doing it all in one go, we're doing 7 plus 3 plus 5. Same for this one here. Instead of doing 7 plus 6 all in one go, we're breaking it down and doing 7 plus 3 plus 3. Well done if you got all of those right. So let's recap some of the learning that we did last week on 2D shapes. Can you pause the video and finish or fill the gaps in these sentences on our success criteria? Well done if you've had a go at that. Let's go through our STEM sentences then. So 2D shapes are flat. Well done if you got that. So 2D shapes are flat shapes. 2D shapes have, now what properties do we describe 2D shapes as having? 2D shapes have sides and vertices. Well done. So a side is a flat or curved line on a shape. Well done. So a side is a flat or curved line on a shape. Now a vertex is another word for a corner. Well done. And that is where our sides meet each other. And what we're going to do today is we're going to bring all of that together to be able to sort and compare shapes on a Venn diagram. But before we do that, let's recap our knowledge of these properties. So once again, you're going to pause the video and have a go at using this STEM sentence here to describe each of the shapes on the screen. This is a, and then name of the shape, because it has sides and vertices. Now remember, not all shapes are regular. That means that only some shapes are regular, meaning they have the same length sides and they look the same whichever way you turn them. Not all shapes look like that regular typical example that the regular shape shows us. So we determine what the shape is called by the number of sides and the number of vertices, not just what it looks like in the regular form. So pause the video and have a go at this. Well done if you've had a go at that. Let's go through them together then. So this is a circle because it has one side, and you might say it's got one curved side and 0 vertices. Well done. If it's only got one side, those vertices can't meet. Sorry, those sides can't meet to create a vertex. Okay, this is a square because it has 4 equal sides. Remember, that's what differentiates it from a rectangle. So this is a square because it has 4 equal sides and 4 vertices. This is a pentagon because it has 5 sides and 5 vertices. Now you might have also noticed that this is not just any pentagon, but this is a regular pentagon. This means that whichever way I rotate this shape, it will look the same because all those sides and these angles here, the spaces within the vertices are all equal. Okay, so this is a, well, let's count. 1, 2, 3, 4, 5, 6, 7, 8. So this is an octagon because it has 8 sides and 8 vertices. And once again, it's not any old octagon, it is our regular octagon. This is a triangle because it has 3 sides and 3 vertices. Now this one is not quite a regular triangle because this one is not quite the same when I turn it. It's very close, but not quite. This is an irregular triangle. This is a rectangle because it has 4 sides and 4 vertices. Remember, it's also got 2 long sides and 2 short sides. This is a hexagon because it has 6 sides and 6 vertices. And well done if you notice that this is also a regular shape. Okay, let's count the sides on this one. 1, 2, 3, 4, 5, 6, 7. So this is a 7-sided shape. It's not a regular shape because it's got some really short sides and some really long sides. So it's not regular, it is irregular, and it is an irregular heptagon because it has 7 sides and 7 vertices. Now this shape has got 4 sides, but it's not a square and it's not a rectangle. Can you remember what we call a shape with 4 sides? Well done, it's a quadrilateral. Let's say that together one more time. Quadrilateral. It's a bit of a tongue twister. Yes, well done. It is a quadrilateral because it has got 4 sides and 4 vertices, and it is an irregular quadrilateral. Remember, the only regular quadrilateral would be the square. Okay, so now after discussing through all those properties, what I'd like you to do now is pause the video and use the sentence starters down here to talk about any similarities or any differences that you may have noticed. And then when you've got some ideas either written down or you've said some ideas out loud, play the video again and I'll share some of my ideas and maybe we got some similar ones. Lovely, well done if you've managed to have a go at that year too. So I'll share some of my ideas then. The square, the rectangle and the quadrilateral are similar because they all have 4 sides. The square and the pentagon are similar because they are both regular. Maybe I could have said that about the square, the pentagon, the octagon, and the hexagon. They are all regular. The heptagon and the triangle and the quadrilateral are similar because they are all irregular. And the rectangle as well, sorry. So the heptagon, the rectangle, the quadrilateral, and the triangle are all irregular. I might say the pentagon, the octagon, the hexagon, and the heptagon all have more than 4 sides. I might say the circle is different from the rest because it is the only shape that has got a curved side. Or I could say the circle is different from the other shapes because it is the only one that has no vertices. I might say the square and the rectangle are different because one is regular and one is an irregular quadrilateral. So there's some of my ideas that I had. Maybe you got some similar ones and maybe you got some that I didn't even think of. If you did get any that I didn't even think of, I would love to see and hear some of the things that you said. So with all that in mind then, what we're going to do is we are going to sort these onto a Venn diagram. Now a Venn diagram is 2 circles that overlap each other and we're going to sort them. Now that means that this circle here needs to have a name and this circle here needs to have a name. So on the examples that you're going to do, you can either choose from here the blank ones like I'm going to model, or you can choose from one where I have already labelled your circles for you. So let's have a look. If you do choose this blank one, there will be some category names that you can use as a prompt. So let's have a look. I think I'm going to choose has straight sides. So I'm going to name one of my circles has straight sides. I'm just going to make these a little bit bigger. And I'm going to name my other circle has more than 4 sides. There we go. So this blue circle is called has straight sides, and this red circle is called has more than 4 sides. So let's have a look at our circle. Does our circle have straight sides? No, it's the only one that's got curved sides. Does it have more than 4 sides? Yes, it does. No, it doesn't. Silly me, I'm falling asleep. No, it does not. So if our circle doesn't belong in any one of these categories, then it needs to go outside of the categories. It can't go in any of them because it doesn't fit under any of these titles. So, does this shape have straight sides? Yes, it does. It's got straight lines, 4 sides. Does it have more than 4 sides? Well, no, it doesn't. It only has 4 sides. It doesn't have more than 4 sides. So it only fits in the blue circle. So it doesn't fit in the red circle. Does this shape, this triangle, have straight sides? Yes, it does. Does it have more than 4 sides? No, it doesn't. So it only belongs in our blue circle. The rectangle then, does our rectangle have straight sides? Yes, it does. Does it have more than 4 sides? No, it doesn't. It only has 4 sides. And this one then, the square, does it have straight sides? Yes, it does. Does it have more than 4 sides? No, it doesn't. So it only goes in the blue circle. This is our hexagon then. So our hexagon, does it have straight sides? Yes, it does. Now, does our hexagon have more than 4 sides? Yes, it does. So if it belongs in both of my categories, it goes in the middle. Can you see this middle one here where it is being hugged almost by both of those circles? This is our pentagon. Does our pentagon have straight sides? Yes, it does. Does it have more than 4 sides? Yes, it does. So I'm going to put it in the middle because it belongs in both categories. So this is our 7-sided shape, our heptagon. Does our heptagon have straight sides? Yes, it does. Does it have more than 4 sides? Well, yes, it does, because 7 is more than 4, isn't it? And this is our octagon. Does our octagon have straight sides? Yes, it does. Does it have more than 4 sides? Well, an octagon has 8 sides, so 8 is more than 4. So now I've sorted my shapes into the Venn diagram, and you might have noticed that there are no shapes that have more than 4 sides that are curved, because remember, to be in here, it would have to have more than 4 sides, but not have those straight sides, okay? So your task for today then is to do the same thing. You've got some shapes here. Now, if you print the sheet off, you can physically cut these out and place them. If you do this on the Word document, you can physically click that shape and drag it to where it belongs and save it. If you are writing this, then what I would suggest is you draw the circles, and instead of drawing the shape, I would write the name of the shape in those circles, just so that there is no confusion. Remember, if you're doing this version, you can choose the names of your own categories, and you might want to do this more than once. See how many different times you can sort those shapes into categories based on their similarities and differences. If you're not very confident in labeling your own categories, you can use the example on the sheet that has been listed for you. Now, the example I have chosen with the names on has more than 4 sides, which is one that I did here. There you go, has more than 4 sides. But I've chosen a different name for this circle here, and that is symmetrical. So remember, this word symmetrical means that it has at least one line of symmetry. If there is a shape that is not symmetrical, it doesn't have any lines of symmetry at all. Remember, that means if I folded it over on a line, would they match perfectly? Then it can't go in this circle. Remember, if you have a shape that doesn't fit into any of those categories, it goes outside of the circles altogether because it doesn't belong in either. Well done, everybody. I hope this has been a fun lesson for you to bring together all your knowledge on 2D shapes. I'm really looking forward to seeing the work that you send in last week until the half term. So keep up all that hard work. We can do it year 2. Bye, everyone.